have started working on Agriculture Digital Innovation Hub. It's a set of tools which should connect people who are interested in agriculture, who have some needs, or on the other side provide some services that they know about each other. It will be a portal where you can find an information, you can share your thesis if you are a student, or if you have any need for a problem to be solved, then you can ask someone to have a look at it, and for example it can become a topic for a new diploma or PhD thesis. So it's a platform for meeting people who are dealing with agriculture, who can share new ideas and new views. And one part of it is also very technical, which I would like to introduce you today, is really the Innovation Hub, which will provide a set of tools and data you can use to develop innovative agriculture applications and share your knowledge with each other, and just to get inspired by developing new applications, having new ideas, and collaborating with our colleagues. We have just started. It's very brand new project. It's evolving. So now I have the opportunity to inform about this Innovation Hub for the very first time. It's built on a scalable architecture of a cloud, and of course, on top of open source technologies. We believe they have a future, and a very bright future, because if we all know that if we compare situation 15 or even 10 years ago and now, the evolution of open source technologies is astonishing. It's amazing. 15 years ago, I wouldn't dare to rely solely on open source technologies. Nowadays, I can do it easily. It will be the Digital Innovation Hub, even for the developers. It will be completely available via web interface, so you don't need any access to server to make something. It will be based on a technology which runs on top of your web browser, so you can get there easily without any VPN or any need for a special communication channel. And you will have an opportunity to test all the tools during Pilsen Hackathon. If we look further how it's composed, so if it's built on a cloud, so down there are physical servers which are connected in a cloud, in a virtual cloud, which is running on OpenStack, and on top of it there are several applications, and one of these applications is just this Agriculture Digital Innovation Hub. There are of course other applications, portals, other servers, whatever. So we are building our new all new tools we are building on top of clouds, and we are changing just to cloud solution because it's flexible, and it's the trend of today's, and it has proven that it's working much better than managing one-to-one relation, one application to one server. So you can easily add some more power if you need it. For example, for hackathon, we would need certainly much more power for the Jupyter Hub, which is powering the whole thing. So we just add some more power using OpenStack very easily by a few clicking. We don't need to do anything with the real hardware, because OpenStack will take care of it. How it looks like from the technical point of view, it's built on Jupyter Hub, which is which is maintained, or which is based on Anaconda manager, which is managing R packages and Python packages, which can be used in Jupyter Hub. Of course, we have installed all libraries or dependencies you would need to use together with remote sensing data. For example, for R, there is a support to GDAL, there is support to remote sensing data processing, and so on. So even though R is originally a statistical software, currently it is also a very strong tool to remote sensing data processing, and even machine learning tools there. And similar tools we also have in Python. So you can, if you run Jupyter Hub, you can select whether you want to work in R environment or in Python environment. And in both environments, we have tried to prepare tools which are needed to work with Earth observation and also spatial data. Here, if I look at the interface of Jupyter Hub, so you can either run R or Python notebook and start the kernel. Here you can see the R kernel. So very easily on some test data, you can see that it can plot. It can even plot the data as specified by the command above. It's just for demonstration, because it's really brand new, so we didn't process any big data or big amounts of spatial data, and we are still building it, and we plan to run it properly for the Pilsen hackathon. So it's just work being done and under development currently, but it's already working. You can see the thing how it's developing. Similarly, you have access to server terminal where it's running. So as I was saying, you don't need to have any special communication channel to the server, no VPN, no SSH connection. You are just okay with your normal browser, and using HTTPS, you can even work on a server. For very quick overview, we have prepared some quick and dirty application where you can see the visualization. There is a database behind. In the database, you have information which is there about Sentinel-2 data. I mean, the nomenclature of the sheet, the track, amount of clouds, and dates of image. And then you can see that using our tools, we have calculated NDVI indices. We have prior to NDVI, we have of course calculated L2A images, because we have been downloading a level 1C without atmospheric correction. So we just wanted to try even module on atmospheric correction, and you can download full size image under the links in the middle NDVI, and also the upper link is to source image in level 2A processing level. So this was the overview as where we are now. For the future, as I was saying, it's really brand new, and still we have many ideas. We are planning to publish results using OGC services. So we are planning to use map server for that. We also are planning to enable web upload of data to process using Layman, which is our own development. It's built on top of GeoServer API, and it enables to upload the data to the server without having or we don't need to have access to it again using REST API. There are many opportunities and ideas on integration of other tools like QGIS, Graph, Airflow Toolbox, and many others, Saga, maybe, whatever. We are also planning to integrate metadata with our Metka catalog. There's also an option to integrate sensor data. For example, on the fields, there can be some sensors on humidity or whatever, so they are sending data very frequently. So you can combine these in situ data with satellite images for having in other nice applications. There can be ideas on geoprocessing services, API access, and so on and so on. So there are really many ideas. This is just for the very beginning, and we're looking forward for the Pilsen Inspire Hackathon to get some more ideas from participants, because that's why we are doing this.